Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised journal test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 233. And today is our lesson number 116. Now listen carefully, please. Today is our lesson number 116. This problem that we are about to do, problem number 2.7.9 on page 233, deals with the concept of compound interest. Yesterday, on day 115, we did a similar problem dealing with the compound interest, the one above it, 2.7.8. And day before yesterday, I did a problem which is not in the book, a simple problem. See, the 2.7.8 has an interest rate of 3.5%, which is annoying. The day before yesterday, I did a similar other problem with the interest rate of 4%. And not only that, but we solved that problem. Day before yesterday, we solved the problem in a step-by-step manual manner without the formula. And then yesterday, we introduced the formula. The formula goes something like this. V, which is the value of our investment at the end of n period. Notice how my formula here that we see here, the formula that you see here, is a little bit different than what you see in the book there, because I make it even more general so that it's easier to deal with. So V is the value of our investment at the end of n periods. Whatever the periods may be, it could be n is obviously some number, it could be 4 months, 4 years, 4 quarters, or even 4 hours, whatever it is. Because this is a very general formula. We can talk about the population of bacteria at the end of 4 hours if it's growing at a certain rate per hour. This is a very general formula. R is the rate of return per period. So the example that I just gave you of population of bacteria, in that case we will not speak of rate of return per period, but we'll talk about rate of growth of population per hour, or rate of growth of population per second even. So the N is very, very general. It does not have to be a year. It does not need to be a year. People have this misconception that when we talk about interest rate, we have to speak in terms of years. You could invest the amount for only 4 months, as is the case in this example, or rather, in this example, the guy is investing it for a year. But anyway, so R is the rate of return per period. So for example, if they tell you that the bank is going to pay you, if they tell you the bank is going to pay you 12% per year, if 12% per year, and the interest rate is going to be compounded every month, then we are dealing with monthly scenario because it's being compounded every month. In which case, you will take the interest that the bank tells you, 12%, because the bank is not going to say per year. Interest rates, when they are stated, it's understood that it is per year. But if it's going to be compounded every month, then the interest rate per month is going to be 1%. So the rate of return per period in this case is going to be 12 over 12, because there are 12 periods in a year. If it happens to be 12% per year compounded every quarterly, as is the case in this example, then whatever the interest rate is, we have to divide that by 4, because there are 4 quarters. In this case, if the bank tells you that they're going to pay you 12% interest, essentially what they're telling you is that at the end of every quarter, they're going to pay you 3% interest on the initial amount of investment that you put in, plus the interest that has been accumulated in your account every quarter, because every quarter is when they're going to adjust the account. Do you understand? So you have to read the problem and ask yourself, how often am I getting paid the interest? Is it per quarter? Is it per month? Is it twice a year? Is it once a year? What is it? Okay, enough said. So R is the rate of return per period, and of course N is the number of periods. So if you're going to keep the money in the account for 2 quarters, then N will be 2. Do you understand? Very good. Let's do the problem. Enough of this. Enough of the talk. Let's do the problem. In this case, we have a guy who needs to earn at least $1,000. We are told that he wants to earn at least $1,000. He's going to make an initial investment. He's going to make an initial investment of $20,000. The question is very simple, very straightforward question, which is, and we are told that whatever interest that he's going to earn, his bank tells him that they compound interest every quarter. So it's going to be compounded quarterly. He's going to keep the money in for 1 year. The question is very simple, very straightforward, which is how much money should he invest initially in order for him to earn $1,000 in interest at the end of the year. That's all. Now before we do that work, this is the compound one. Let's do another scenario. Let's ask ourselves a very simple question. What would the interest rate have to be if he were to earn, if he were, it's a hypothetical question because that's not what we're dealing with here. If he were to earn simple interest. Well, if you're earning simple interest and you want to earn $1,000, then basically you want to earn $1,000 on an investment of $20,000. Well, that's very straightforward, very simple. It's just 1 over 20, which is 5% per year. If the bank pays you 5% interest on an investment of $20,000, you will have your $1,000. Because you see, 10% of $20,000 to 10% of $20,000 would have been $2,000. If 10% is $2,000, then it stands to reason that 5% must be $1,000. So simple interest is 5%. Therefore, that tells us, this part, this inside tells us that answer here in this problem, when it's compounded, whatever it is, first of all, is going to be less than 5% and it's going to be slightly less than 5%. It's not going to be 4% or 4.5% or 3%, it's going to be just slightly under 5%, that's all. That helps you eliminate the wrong answers. You can knock out probably 2 or 3 answer choices just based on that insight. If any answer choice that you see there, which is more than 5%, when you compound it, you need to earn lesser amount of interest, lesser interest rate rather, if the amount of interest that you're going to earn is fixed. You understand? So let's solve it. I'm talking too much and we're not actually solving it. Let's set it up. Let Q be the interest rate per quarter. As you can see, I'm setting it up very differently than what you see in the book. In the book, they deal with they like to be in a straitjacket where, for some reason, to them the interest rates have to be studied on a per year basis and so forth. It's per quarter. It's per quarter is what. So we're going to solve for this Q. Q is our unknown, which represents here the interest rate per quarter. But of course, the interest rate, as we already know, are studied on a yearly basis. One does not go around saying, my bank pays me 3% interest per quarter. No, one does not. Interest rates are always studied on a yearly basis because that's the convention, that is the norm, that is the tradition, that is how the banking system is run. So when we solve for Q and once we have the answer, at the end all we have to do is multiply that answer by 4. That's all. That's all we have to do. When we solve for Q, at the end when we find what Q is, if Q happens to be 1, well the yearly interest is 1 times 4, 4%. If Q happens to be 1.5, 1.5 times 4, well the yearly interest is 6%. And therefore the quarterly interest is going to be 1.5%. So we're just going to multiply our answer by 4 at the end and that's it. That's how I'm setting it up. So I'm not solving for the interest rate on a yearly basis, we are solving for the interest rate on a quarterly basis. That's what I want you to understand. And of course there are 4 quarters. Therefore, the balance in the account at the end of the year, the balance in the account at the end of the year is what we are calling the V. V is the value of our investment at the end of the year. So this is our V. And we're just going to plug in that formula. This V has to equal our initial investment of P, which is, P is our principal. I hope I spelled it correctly. Yep. P stands for the principal or the initial investment, if you like. P is our initial investment. So that's your P times 1 plus R, which in this case is our rate of return per quarter, which we are calling Q. And how many quarters are there in 1 year? We're going to keep the money in the account for we're going to keep the money in the account for 1 year. And 1 year, of course, has 4 quarters. So our n here, in this case, equals 4. N here equals 4. Because there are 4 quarters in a year. Because there are 4 quarters in a year. Now I shouldn't actually write it like this, okay? I want you to understand. I shouldn't have actually written it like this because that makes it sound like n equals 4 and it's fixed forever and ever in this formula. That is not the case. What I meant here is that our n here is 4 because we are keeping the money in the account for 4 quarters. That's what I meant to say. Had we been keeping the money in the account, had this boy decided to keep his money in the account for a year and a half, n would have been 6 because a year and a half he would have had 6 quarters. So let me rewrite it. That's not proper. N equals 4 because we are keeping the money in the account for 4 quarters. Because we are keeping the money in the account for 4 quarters. We're keeping the money in the account for 4 quarters, 1 year, right here. We're keeping the money in the account for 4 quarters, for 1 year. That's why n equals 4. Not because there are 4 quarters in the year. That's not what I meant to say. That's what I said, and I just wanted to make sure that you understand. That's it. That's our formula. All we're going to do now is to plug in our values for different for P. Our initial investment is $20,000, and we want, how much does he want at the end of the year? Well, he wants to earn $1,000 in interest, which means if he starts out with $20,000, at the end of the year, he wants to walk out of the bank with $21,000 in his pocket. So that's our V. That's the value of our investment at the end of the period, at the end of our n periods. V is the value of our investment at the end of the n periods. At the end of the n periods, at the end of the 4 quarters, he wants the value of his investment to turn from the initial $20,000 into $21,000. Hence the $1,000 in interest. So that's it. That's what it is. V equals $21,000. Our initial investment was $20,000. Our n is 4. And we know P, we know V, we know N. Our N is 4. And we solve for Q. That's all. That is all. This is our N. I need the room, so I'm going to do it on the top. Again, one more time before I re-raise it. What it says here is that we need to earn at least $1,000 on the initial investment of $20,000. That's your P, the principal, $20,000. The bank tells us that they're going to compound the interest every quarter, quarterly compounded for 1 year, and therefore there are n equals 4 because there are 4 quarters in a year. And that's it. All we have to do, as I said, is solve this equation. So V equals $21,000, which has to equal P, which is our principal, which is $20,000, (1 plus Q raised to 4. My handwriting is getting more and more sloppy. 1 plus Q raised to 4. That's it. That's all it is. We're done. We just have to solve this equation, and that's all there is. Let's do it then. Let's solve it, shall we? Very first thing I'm going to do before we go any further, keep our life simple. Divide both sides by 1,000. If you divide both sides of the equation by 1,000, we can knock out the 3 zeros. Okay? And then divide both sides by 20. If you divide both sides by 20, then what we end up is 1 plus Q raised to 4 equals, this 20 is going to end up here, 21 over 20. Divide both sides of the equation by 20, as I said. That's it. Therefore, 1 plus Q should equal 21 over 20 and a 4th root of that. Now this is not something, as you know, if you've been watching my videos for a while now, you know that I absolutely abhor having to reach for the calculator. I do not like it. I detest it. I prefer to do everything manually. But this is not something you can do manually. Here, you will have no choice but to resort to using the bloody thing. So you have my blessing. Reach for the bloody thing. Type in 21 over 20. I'm going to do it with you as a matter of fact. Well, I can't do it with you because I left my calculator in the other room. Bloody hell. Well, you're gonna have to trust me on that. Actually, I've already done it. 21 over 20. Let's erase this part. We don't need any of this thing here. (21 over 20 is 1.05, and we need to take a fourth root of that. Sometimes I put this kind of parenthesis, sometimes I put that kind of parenthesis. It really has no meaning. The shape of the parenthesis, of course, is insignificant. It doesn't matter. Like whether you use this parenthesis around it or this one or that one, I get sloppy. So how do you find the fourth root of 1.05? The easiest, the quickest, the simplest way in a calculator to figure out the fourth root. Don't go over 1 over n exponent and so forth. That's annoying. That's annoying. Just take the square root of something and then take the square root again. So if you take the square root of something, if you take the square root of this quantity and then take the square root one more time, you will find that that quantity equals 1.01227, and that's your 1 plus q. But we're not interested in 1 plus q, we want to find the q. So subtract 1 from both sides and your q equals 0.1227. That's it. That's it. Now if you want the intermediate step, I can actually show you the intermediate step. If you take the square root of 1.05, the square root of 1.05 is 1.0247, and then take a square root one more time. Because if you take a square root of something and then take a square root again, you're taking the fourth root of it. And of course the fourth, if you take a square root of this quantity, I just wrote it, which is 1.01227, and that's your q. Now what does q represent? Q represents the quarterly rate of return. All we have to do is multiply that amount by 4. Therefore, the yearly rate is Q times 4, which comes out to be approximately 4.491 or 4.91%, approximately 4.91%. That's it. The quarterly rate, as we just found, turned out to be 1.227 per quarter. 1.227. That's all. You see how little difference it is? In a simple interest, if you're getting 5% simple interest, if you were to divide that by 4, that would have been 1.25% per quarter. Instead of 1.25%, it is 1.227. Instead of 1.25, this digit being 5, it's 27. That's your compounding effect there. So even if the bank pays you 1.227% per quarter, that is same as earning 1.125% interest per quarter, 1.125% interest per quarter, if the bank were paying you simple interest. I'm going to say it one more time, and of course you can rewind it. In the case of simple interest scenario, you would have had to earn 1.25% interest per quarter, because there are 4 quarters. So 1.25 times 4 would have given you the 5% interest that we need, because 5% of $20,000 is $1,000, which is what we want to earn. But because of the fact that the bank is compounding, we don't have to earn 1.25% interest per quarter. We would be just as happy to earn 1.227% interest per quarter. That's all. That's all it is. It's too much talking. We'll see you tomorrow on day number 117. I'm done with for compound interest concept. Starting from day number 27, starting from day number 117, tomorrow we'll start the geometry, which you see there at the bottom of the page 233. They start talking about the concept of geometry, and we're going to learn a little bit of geometry. There's some basic concepts of geometry that you must have at your fingertips if you're going to do well on the exam, because there are a lot of geometry questions on the GRE, as you already know. Alright, I'll see you tomorrow. Bye now.